Today I will show you how to set up real-time facial motion capture in Unreal Engine using your iPhone and combine it perfectly with body animations, even if your character has a modular head and body. Don't worry, I'll take you through it step by step. If you prefer a written tutorial or just want screenshots of the blueprints and setup, go to filmdaft.com. I'll put a link to a written tutorial in the description, but here I'll show you how to set it all up from beginning to finish. First, grab your iPhone and go to the App Store. Download and install the LiveLink Face app. Now, it says on the website that you need an iPhone 12. I've got an iPhone 11 and it works just fine with that as well. You should be fine if your iPhone's camera has the True Depth technology implemented. Apple did that around 2017. Now, you need to find the IP address for your local network, which you need for connecting the LiveLink app with Unreal Engine. If you're on Windows, as I am, you can find your IP address by opening Command Prompt and typing ipconfig. Look specifically for the IP4 address under your active network adapter. If you're on a Mac, go to System Settings, click on Network and find your connector network. Your IP address will be listed right there. Now open the LiveLink app on your phone and tap the settings gear icon in the top left. Then tap on Target and add your PC's IP address, which I've already done here. Scroll through the options and set protocol to 4.25 or later. Turn on Live at Startup. Stream head rotation and blend shape data. Scroll further down and set video quality to medium for best performance. Now open your Unreal project. Head to the top bar, click Edit and go to Plugins. In the search bar up top, type LiveLink. Check the box to enable LiveLink. Also, enable Apple ARKit face support and UDP messaging. These will ensure that Unreal can talk to your iPhone and properly handle facial and body motion. Once those are enabled, restart Unreal to ensure everything loads correctly. Back in Unreal, open the drop-down menu called Window, go to Virtual Production and choose LiveLink. It should appear with a green dot. That means the connection is live. Now let's import your character. In your content browser, right-click and create a new folder. Maybe call it Characters to keep things neat. I already have that, so I'll call it Characters 2. Right-click inside that folder and choose Import to Characters. Find your FBX file and open it. When the import options pop up, scroll down a little and make sure Import Morph Targets is checked. That's super important. These morph targets will drive the facial expressions. Once that's set, just click Import All. Open the skeletal mesh and play around with the morph targets to see if everything looks as it should. You can also assign the materials you want to your face, but you can choose to do so later. Note that you don't have to have morph targets enabled when you import the rest of the body. That's just for the face. You can import it as FBX or add it directly from a package you purchase on Farb via the Epic Games Launcher, as I've done. Right-click in the content browser, go to Animation and Animation Blueprint, and select your skeleton. Name the head Blueprint, ABP_head blend. Open it up and go into the AnimGraph. Right-click and add a LiveLink pose node. Connect it directly to the final animation pose. In the Details panel for the LiveLink pose node, set the subject name to match your phone's name. Now switch to the EventGraph, add and evaluate live link frame node, and set the subject name to your phone again. Hit compile and save. Now the basic facial blend shapes should work and move when you film yourself with the LiveLink app. However, we still need to create head rotation and make it possible to blend the body and facial animations. If you don't see your head moving, go to the Details panel on the right, scroll down and find Update Animation in Editor. This will let you see animation updates instantly inside the editor without needing to press play. Also, remember to set animation mode to use animation blueprint and the anim class to the name of your animation blueprint. Next, let's create a new blueprint class and choose character. Name it BP_modular character. Now let's set up the modular character. The important thing here is that every asset you use for the body is assigned to the same Unreal Engine skeleton. I use a character based on the Unreal Engine 4 skeleton, so I choose all assets I might want to use, right-click and choose Assign Skeleton. Then I'll choose an Unreal Engine 4 skeleton. I'll just type in UE4 in the search bar and pick the first one for this tutorial. Then click Accept. Now let's choose the body parts for our modular character. Add a skeletal mesh component for the body and add the rest of the body components you want. If your character only consists of a single body mesh and a head, you don't need to add more body components. Set the body mesh, in my case SK Petite Female Tank, as the root component. Then add the head mesh. In the construction script, set the body mesh to act as the leader pose component. Then add the rest of the body components as targets. This ensures the body animation drives the skeletal hierarchy correctly, while the head is independently animated through LiveLink. Open up your animation blueprint for your face and choose the EventGraph. At 3, get property value nodes, one for yaw, one for pitch and one for roll. You can duplicate the first one quickly with Ctrl+W. rename them clearly as head yaw, head roll, and head pitch. Next, add a map range climbed node for each property. For yaw, set in-range A to -1 and in-range B to 1. Set the outrange A to -90 and outrange B to 90. For roll, set in-range A to -1 and in-range B to 1, and set the outrange A to 70 and outrange B to -70. For pitch, again set the in-range from -1 to 1 and set the outrange from 60 to -60. You can change these values if your character's head rotation is too extreme or small. Wire the value from the get property value into the input. Now add a make rotator node. And wire yaw into X roll, roll into Y pitch, and pitch into Z yaw. Go down to variables and create a new variable called head rotation. Set it to rotator. Drag it into the event graph and choose Set Head Rotation. Connect the Make Rotator to the Set Rotation node. Create a sequence node and wire the event blueprint update animation into it. Then wire the then 0 pin into the Evaluate Live link frame node. Now create a Get Owning Actor node, which we cast into the modular character blueprint we created earlier. To do this, simply right-click in the event graph, type Cast, and choose your character blueprint. Connect the return value of the Get Owning Actor node to the object in the Cast to Character node. Then wire the then 1 pin into the top pin of the Cast to Character node. Next, create a target node and choose Set Morph Target for the leader bone component you selected in the modular character blueprint. In my case, it was the tank top. Delete the Set Morph Target node that follows. Under Variables, create a skeletal mesh component for your body leader bone component and drag it into the event graph. Connect the cast to character and the target node to the set node you just created. Now connect the data result of the Evaluate Live link frame node to the Get Property Value nodes you created earlier. Finally, connect the Evaluate Live link frame node valid frame pin to the Set Head Rotation node. Remember to hit Compile and Save, and now the event graph is done. Now let's finish the AnimGraph. Start by dragging the skeletal mesh from under variables into the canvas. Now add a copy pose from mesh node. Also add a new cached pose node by typing in pose. Rename it to input cache and connect the 3 nodes. Next, drag the head rotation rotator variable into the canvas and add a local 2 component node. Connect the output pin from the live link pose to the local 2 component node. Now add 2 transform bone nodes and link them up with the local to the component node. Next, connect a multiply node to the get head rotation node. Choose a value that works for your character's head. In my case, I find that 0.7 works. Now connect the multiply node to the rotation pin of the series' first transform modify bone node. From the second transform bone node, drag out from the rotation pin and choose a multiply node. Again, set a value that works for you. I chose 0.5. Now add a second component to local node. And a default slot node. Connect the local to component node to the last transform modify bone node. Connect the default slot node to the local to component node. Next, create a use cached pose node and choose input cache. Add a layered blend per bone node. Connect the default slot node to blend poses 0. Connect the cast pose to base pose. Then hook this up with the final output pose node. Now we need to set the right bones for the transform bone nodes. Choose the first one in the series and in the details panel under skeletal control, choose your neck bone. Scroll down to rotation and set the rotation mode to replace existing and the rotation space to bone space. For the second transform bone node, choose the head. And again, set the rotation mode to replace existing and the rotation space to bone space. Now create another use cached pose, choose input cache and connect it to the input pose of the live link pose. This allows you to use the live link in real time while the head is attached to a body with an animation. As always, remember to hit compile and save. Now choose the layered blend per bone node. In the details panel under config, add an array element. Add a branch filter element and expand the index members. Under bone, type in the name of your relevant neck bone. Remember to type it in exactly as it is named in the skeleton. Again, remember to hit compile and save. Back in the editor, in the details panel on the right, scroll down and find update animation in editor. Make sure you check that box. This will let you see animation updates instantly inside the editor without needing to press play. Now let's bring everything together inside Sequencer. Create a new level sequence or open an existing one. Add your BP modular character to Sequencer by clicking Track and choosing Actor to Sequencer. Choose your face and the leader bone component. For the head mesh, set the animation mode to use animation blueprint and assign your face animation blueprint as the anim class. For the body mesh, use the leader pose component you set earlier and assign whatever baked animation you want, like a walk cycle. You can even record a live link face performance ahead of time and import it as a baked animation track if you want everything clean and editable. Now, when you press play, your modular character's body will animate normally, while the face updates in real time based on your iPhone's facial mocap. That includes proper head rotation. And that's it. Real-time facial mocap combined with modular body animation, fully working inside Unreal Engine. If this helped you out, smash that like button, as the YouTubers say these days, and don't forget to subscribe. See you in the next one.